Hello, getting everything set up here. Thank you for joining me. I'm going to share my screen. There we go. So let's talk about this. Let's talk about this is Hart Hagen with Food and Climate on the Food and Climate Facebook page. So let's talk about a rapid transition from industrial farming to regenerative farming. This will be about maybe 15 minutes, rough guess. So how to do this, and mainly why to do this transition from industrial farming to regenerative farming. It's very important that we do it, and everybody can participate because everybody eats. And so let's go from there. So why farming? So we're talking about climate change, biodiversity, environment in general. Why are we concerned about farming? That's because farming acre by acre changes the world. How we do farming, how we grow food, acre by acre, square mile by square mile changes the world. We've been taught to look up into the atmosphere to figure out why things are going awry. Why are we having all these strong hurricanes? Why are we having all these extreme weather events? Look up at the CO2, the carbon dioxide in the air, and we're taught to ignore everything all around us, whereby we're changing the land acre by acre, square mile by square mile. Deforestation, poor treatment of soils, chemical pesticides, herbicides, the way we treat the water, what we do to the water. But farming, it changes the world acre by acre, hectare by hectare, square mile by square mile. So why farming? Because it is the most consequential. Out of all the things we can do, it's more consequential than, in my view, than transportation and defense. And I hate saying that because defense is very consequential and transportation is very consequential, but farming is the most consequential out of all these things. And it's the area in which we have the most control. Everybody eats. And everybody, if you choose to, can grow something, or you can get your food from other people who grow food locally. So it's the area in which we have the most control. It's a whole lot easier to control the farming sector, as vast as it is, as much as it is in the thrall of these big agribusiness corporations. It's still something that we can do step by step. And why do we need a rapid transition? Let me change my screen just a little bit. Why do we need a rapid transition? And that's because this is very important, that it's very urgent, and there's no reason not to. So the topics in this talk will include, it'll just be about 15 minutes here. Topics in this talk will include soil, carbon, water, nutrition, and how all these things, how one form of farming or another is going to impact our soil. One form of farming or another is going to impact the carbon, our water, the water cycles, our nutrition. Whether you have industrial farming or regenerative farming, either way, it's going to have a big impact on nutrition, soil, carbon, water, and other issues. So let's talk about the issue of carbon and how it's different if you have industrial or regenerative. Well, in industrial agriculture, food travels long distances, 1,500 miles on average. That's a lot of transportation cost. But in regenerative agriculture, food tends to travel shorter distances because there's more of a tendency to buy food locally and to grow food for local consumption. Food travels shorter distances. How else does industrial or regenerative farming affect carbon? Well, when in industrial farming, carbon moves from the soil into the atmosphere. all this tillage, all these synthetic fertilizers are attacking the soil and killing the soil. And whatever life the soil has, the carbon is moving from the soil into the atmosphere. On the other hand, in regenerative farming, carbon is moving from the atmosphere into the soil. It's going the right direction. Don't we need to move carbon out of the atmosphere? You bet. So in regenerative farming, the way it's set up, it moves carbon from the atmosphere into the soil. How else does the choice between industrial and regenerative farming affect carbon? Well, in industrial farming, you have fertilizers generate carbon emissions. So mainly nitrogen fertilizers. There's this Haber-Bosch process that was pioneered in World War I, perfected in World War II, where we take nitrogen from the atmosphere and put it into a chemical form. And that's what nitrogen fertilizers are made of. It takes a lot of energy to do that. They use natural gas to do that. It takes a lot of energy to make nitrogen fertilizer. Approximately 10 calories of energy packed into nitrogen fertilizer is required to make 1 calorie of food. And the effect that that has, of course, you know, these fertilizer factories are just belching out a whole lot of carbon in the process of taking this natural gas and making nitrogen fertilizer. I'm not supposed to be telling you this. When was the last time you heard this? You haven't heard it lately, unless you're an unusual person. So in regenerative farming, by contrast, there's little or no use of synthetic fertilizers, synthetic nitrogen fertilizers. So it's an entirely different world. We're talking about choices here. Forests, industrial agriculture versus regenerative. Industrial agriculture involves deforestation. Ever since, from time immemorial, clear the land to plant crops, clear the land to plant row crops. And it's getting worse all the time. Farms are getting fewer and bigger. Plant fence row to fence row, and then get rid of the fence row because the farms have been consolidated to grow corn or soybeans. And lots of deforestation goes. Some deforestation occurs. You've been led to believe that deforestation occurs because they're using that land to graze cattle. Sometimes they're deforesting for the value of the timber, and then the cattle is just an afterthought. You got to do something with it. So you put cattle on it as an afterthought after the deforestation for the value of the timber. But industrial farming causes lots of deforestation, whereas regenerative farming, you're reforesting. You've got biologically diverse farms because regenerative farm is going to be biologically diverse. You're going to have tall trees, short trees, bushes, and you're going to have a diversity of plants, and you're going to have a diversity of animals in a regenerative farming situation. So that is reason for reforestation. Also, in a regenerative situation, you're conserving water. Whenever you're conserving water, you're probably going to have more trees. Next, let's talk about water and climate change. Water is big in climate change. That's a whole other topic, but water governs 95% of the heat dynamics of the Earth. Water is a big factor in climate change. We have broken the water cycles, and that causes drought and desertification and hurricanes and floods. So what we want to do, we want to conserve water. Regenerative agriculture conserves water because you've got more plant matter. You've got more plant matter for more of the year. You've got more trees. You've got living roots in the ground. You've got healthy soils whenever you have regenerative agriculture. Industrial agriculture, on the other hand, squanders water. You're deforesting, you're plowing up everything, you're assaulting the soils, you're destroying the structure of the soil. Because if the soil has structure, the soil comes to us with structure. And then we plow it and destroy that structure. So therefore, we squander water because it's the soil structure that enables it to absorb water. That's the soil carbon sponge, which exists and it grows if in regenerative agriculture, but it gets destroyed in industrial agriculture. Let's talk about soil some more. So in industrial agriculture, soil is dead. Just add nutrients. In other words, just add fertilizers, additives. We're going to do a soil test and we're going to give you a list of things you need to add to the soil. You can do some of that, but we do way too much of that. So in industrial agriculture, the soil is dead. The soil is inert. The soil is just a powder. But in regenerative agriculture, soil is a living system. It is a biological system, the way it is in nature, because regenerative agriculture mimics nature. In regenerative agriculture, we're trying to imitate nature. So soil is a living system. It's a biological system. As a consequence, when you have a regenerative situation, when it rains, the soil absorbs the rain instead of just in industrial, you get erosion and runoff and pollution going into the streams and rivers, because in an industrial situation, the soil has no structure. The soil is dead. The soil is powder. Two different things. Let's talk about how else this choice involves soil. Like I've been saying, in an industrial situation, soil the industrial farming model destroys soil structure through tillage and through fertilizers. Synthetic fertilizers kill the soil because they harm the ability of plants to attract to themselves what they need. In regenerative agriculture, you have a soil carbon sponge, and it absorbs carbon and water. The soil has structure. I keep saying that, but soil is like, it's these mineral particles. If it's a good, healthy soil, it's mineral particles that are bound together by a network of organic material. And that it's like a lattice or bed springs. There's space in between the solids, and there's about, in good soil, it's about half to 2/3 empty space, and that empty space can be filled with air and water. That's the soil carbon sponge, and you have water and carbon flowing into the ground. And that's a good thing because moist soil absorbs more carbon. So you can see how this makes a big difference. This choice is a big difference for climate. It's a big difference for biodiversity. It's a big difference for water quality. Let's go on. Also, in industrial agriculture, dead soils cannot effectively deliver nutrients to the plants, but in regenerative agriculture, soil biology delivers nutrients to the plants for plant health and for human health. We need nutrients. We need some metal, iron, zinc, etc. vitamins A, B, C, D, riboflavin, all that stuff is delivered to the soil in a delivered to the plant in a biological system. So think of any vegetable you might want to eat: green beans, potatoes, squash, corn. It comes to the plant. A nutritional plant gets its nutrition from healthy soil biology. So in regenerative agriculture, soil biology delivers nutrients to the plants for plant health and for human health. Let's talk about soil structure and function. I've already talked about this a lot, but industrial agriculture, you've got heavy tillage that destroys soil structure. In regenerative agriculture, you'll use tillage rarely, if ever. Never say never, but tillage is an occasional thing, not a routine thing in regenerative agriculture. Synthetic fertilizers, industrial farming makes heavy use of synthetic fertilizers. Regenerative farming, I think there's a typo there. Use synthetic fertilizers rarely, if ever. Biocides means pesticides, insecticides, herbicides, fungicides, things that kill things, substances that kill things, man-made substances that kill things. Heavy use of biocides in industrial agriculture. In regenerative agriculture, little or no synthetic biocides. So how do you do healthy soils with healthy soils? So how do you have healthy soils with regenerative agriculture? On the right side here, you have plant diversity for good soil biology. Industrial agriculture has monocrops, and that's low biological diversity. Biological diversity is good for healthy soils. Healthy soils have biological diversity. Industrial agriculture, it destroys that. Regenerative agriculture nurtures that soil biology. Industrial agriculture, you let crops lie fallow, idle for part of the year. Regenerative agriculture, you're going to have living roots in the ground at all times. That builds healthy soils. In industrial agriculture, assuming you're growing crops, you're not going to have any animals there. In regenerative agriculture, you're going to incorporate animals. You want biologically diverse farms, they're going to incorporate animals. Industrial agriculture, you're not going to use much that would be called compost. Regenerative agriculture, you're going to incorporate compost and organic matter. This is all good for healthy soils. So I'm almost done. So toxins in industrial agriculture, you're going to have lots of herbicides, insecticides, and synthetic fertilizers. In regenerative agriculture, you're going to have little or none. So we're talking about all the reasons why it's important to switch from industrial to regenerative. We're almost done. Conclusion. Regenerative farming is good for climate, biodiversity, soil, nutrition, and water. And recommended resources. I've got too many recommended resources here. We could stop. They're all good. Don't be overwhelmed by this. Dirt to Soil by Gabe Brown is excellent. Most of what I know, much if not most of what I know, I've learned from this book. Restoration Agriculture by Mark Shepard is excellent. I was reading Restoration Agriculture when a light shone from heaven and said, you can have biological diversity with agriculture. Farms can be wildlife habitat. They don't have to drive out all the animals and all the wild animals. But there's a lot to restoration agriculture. You're trying to mimic natural systems, trying to restore water cycles. You're trying to absorb carbon. Holistic Management by Alan Savory is excellent. Alan Savory is a real guru in the area of, hey, maybe cows aren't the problem. Maybe cows are the solution. If you use them correctly, and if you can use cows to restore ecosystems and water cycles and store carbon in the ground, it's this whole big thing. The Omnivore's Dilemma by Michael Pollan. He starts with the industrial, like 4 sections. The industrial food system, the industrial organic food system, which is not a whole lot different from the industrial food system, and then industrial organic, and then the real organic. He visits Joel Salatin's farm in Virginia. And we're going to talk about how farming should work economically, ecologically, etc. And folks, speaking of Joel Salatin, folks, This Ain't Normal by Joel Salatin. Excellent book. And it's like what we've got for the last 70 years is not normal. So let's talk about what normal should look like. And normal should look a whole lot more like Joel Salatin's farm in Virginia than what we have now. This has been Rapid Transition from Industrial Farming to Regenerative Farming, and written by me. Thank you. And that's the end of the slideshow. We'll see if anybody joined us on Facebook Live, etc. So I think that's about it. Let me click out of this thing here. One of these days I'll learn how to do this. So stop share, stop screen share. And thank you for joining me.